In this video, let's get loopy with loops. Let's get to it. If you're new here, don't forget to like, share, and subscribe below, and you'll get more content like this. So let's go ahead and talk about loops. So with loops, essentially they work like if you have some sort of logic, it will continue to run until a condition is met. And that's very similar of a if-else statement, but with this, it will actually continue until it's met. Instead of seeing if a condition is met, then it will run the logic. So it actually works a little bit different than conditionals, but there are some similarities and differences, but these are actually two different things. With loops here, they would run some logic until the condition itself is met. If you haven't seen the video of the if-else, go ahead and click on this card right up here somewhere, and you can go ahead and check that video out. So let me tell you what each of the loops are used for. Essentially what they're used for is that they're really good if you have to do things multiple times or if you need to iterate through items. What iteration means is that you're able to go into each of the elements inside of a whole collection of elements one by one, and you're able to perform logic on each of those elements. So that's another reason why you would be able to use loops or some sort of an iterator. And they're also really good for counting. If you need to count something, instead of counting them one by one, you can actually just throw it into a loop and it does it a lot more efficiently and faster. And when we are building out our loops, the condition that we are trying to be met, it will be contingent. What contingent, that means that it's not tautological, is not contradiction. Or else if it is tautological, you'll get something called infinite loop. And if it's contradiction, then the loop will never run. So we need to be somewhere in between where the condition itself could be true or it could be false. And you also need to have it for it to be met. So let me show you a loop structure. And this is a different structure than what you are used with conditionals. So essentially you would have some sort of a logic here on the outside, and then you have whatever loop that you're using. There's this while loop that we have here. There's also other loops. We'll get into that a little bit later. The condition that is going to be met, and then the logic that you're performing while the condition is not being met yet. And you have some other logic here to help you get out of this loop afterwards. So that's basically the structure of what you have with loops, is a condition and what you'll be doing until the condition is met. And for the condition itself, it's not tautological and it's not a contradiction, meaning that with this, it can't just be true or it can't just be false. It has to be evaluated to true or false, or else you will run this logic always, or you won't be able to run the logic always. So that is the 2 cents on the condition itself. And it's very similar to all conditions that you'll be writing. So just know that it can't be always true or it can't be always false. But when we have it always true, there's actually a term for that. And that is called an infinite loop. So here on the right here, we actually have an infinite loop. And if we run this code, what will happen is that since this condition is always being met because it's true, this will print out forever, infinitely, until you run out of memory or battery or whatever service that you're using, it will always run. So this is why you should avoid infinite loops, because you don't want this to run an infinite amount of times or to always be running, because it could be very detrimental to your program. And if you happen to somehow write your conditions or write your logic into an infinite loop, before I even go into loops, you should learn how to stop a loop. So to be able to stop a loop in most language, you should be able to stop the iteration or have some sort of escape key, something like that. Make sure you know what those are before you write your loops, just to combat a case of where you have an infinite loop here. So we need to avoid infinite loops as much as possible. Essentially how it works is that if you're trying to avoid infinite loops, you have these 2 things. And this is actually what you would need to make it a really good loop. The first one is called the base case. And then the second one is called the induction step. Because with this kind of logic, it doesn't have a base case and it also doesn't have an induction step. So that's why you are getting an infinite loop when you run it this way. So with the base case and the induction step, let me show you what that looks like. And it actually looks something similar to what we have here in our first example. So the base case is what you start off with. And what we're starting off with is x equals to 0. And then we need to build out our condition. So it's not always true or it's not always false. So this one is okay. We're saying that as while x is less than 5, that one's the okay condition because that will give you true or false, not one or the other. And then our induction step is actually on this line right here. And essentially what the induction step is that it's a way for you to get out of the loop eventually. So for this, what we're doing here is that we're slowly incrementing each of the individual number every single time that the loop is being run. So if we run our code, how this will work is that it will eventually stop. It won't work an infinite amount of times. So with this going on, we have 0 here. And the first iteration, because 0 is less than 5, it will run. So we'll print out a hello. And then we increase 0 by 1. So that will be 1 now. 1 is less than 5. It'll print out hello. And then another one for 2. And then 3. And then 4. And then finally, when it reaches 5, it's not less than 5, then it will break out of the loop. So it actually prints out 4 hellos until it finally goes out of the loop. And that's what you want to have happen with these loops, is a way to get out of them. So that is what the base case and induction step is the base case is what you start off with. The induction step is how you get out of the loop eventually. So now let's go into different types of loops as well as different types of iterators, because iterators actually work the same way as loops. You're still going through each item at a time and performing logic. And these are the ones that you see here. Those are the most common ones. I didn't include all of the loops because it really depends on language again. And also there's a lot of them. I wouldn't remember all of the loops. I just remember how they work and remember probably 1 or 2 of them that you use the most. For me, I know how to use a for and a while loop as well as all these other loops. But the ones that I use the most is for, while, and a map. So those are the 3 that I use. You might be using something different once you learn them. So I would just focus on how they work more than the individual ways of how you can write each of them. And over here, these are the keywords, very similar to the one inside of the conditionals that you can use to pair off with loops. And we'll see how each of those work as well. So with all these loops and iterators, they actually all work the exact same way. It's just different ways of doing things. So once you learn how to do it one way, you actually know how to do it in other ways with the other types of keywords here. And they're just different ways of doing the exact same thing. So now let's go into our first loop, and that is the for loop. And this one is a very famous loop that multiple languages uses a lot, and preferred is this for loop here. So essentially we have an array of colors here of red, blue, and green. And if you need help with arrays, there's going to be a video right there, as well as in the description below. So essentially what I'm doing is that when I'm looping through each of the colors, I'm going to print out each of the colors. So essentially with this loop, keyword is for, and I need to have some sort of a iterator, some sort of a base case. So with the base case, I'm having I, or is short for index, to be 0. And the condition is as long as I is less than the colors.length, what this will give you is however big your array is. So as long as the number is less than how many items are inside of the array, that means that we're able to loop through each and every single one of these. Or else you'll essentially hit a infinite loop. So that is the condition here, is we will keep running until the length of the array here. And then we have our induction step, which is I++. So we're incrementing this by 1 every single time that we loop through each item, and we will eventually meet this condition and break out of this loop. So for the for loop, what it will do is that it will start off with the index of 0, and it will loop through each of the colors index here, and then it will print out red, and then blue, and then green. So technically you can have this be printed out in other ways, but the most efficient way is with the iterator as well as a loop. So that is one way you can use the for loop here. And it does look a little bit different. Just note that this is the base case, this is the induction step, and this is the condition here. Now for the next couple, they will be pretty much the same inside of all of the things that it's trying to achieve, which is just print out all the colors from the array. And they're just different ways of doing the exact same thing. For example, for this for n, the keyword is still for, but then we have an end here. So it looks a little bit different inside of this loop. And how this works is that we are letting color in colors. So as we're looping through each of these elements, we're calling each one of these color. So this is color, that is color, then that is color every time that we go through each of the iterations. Inside of colors, that's what we are looping through. We're printing out each of the colors. So that's just a very different way of writing a loop, is a for n loop. Again, this is what each of the elements are referenced to and what you are looping through. Very similar is the for of, and the difference between for of and for n is just different syntax. Instead of n, it uses of, and it works the exact same way. So in your language, it might use an in or it might use an of. Now let's go into the while loop. And the while loop is another famous one, or one that you might be using a lot. And here you have the base case here at the very top, and then you have your condition here. So why I is less than or equal to the colors.length, and then the induction step and what you're doing for the logic. So that is a while loop. A do while works the exact same way. It's just a different way of writing things. So do whatever's inside of these curly braces while this condition is true. So that is the do while. So with the iterators, you're able to use different types of functions to go through each of the values or the key value pairs, or even values inside of arrays. So they're really good for looping through a collection of objects. And these are actually functions more than loops. So with the map, what we're doing is that we're mapping through all of the colors. We're calling each one of those as a color. So each of these elements are color, and we're just printing out each of the colors. So they work a very similar way with loops, but they're technically are iterators. Another iterator is the for each, works the exact same way, but instead of dot map, you're using dot for each. And very similar with that is the each with index. The only difference between each with index and all the other ones is that we do have the different keyword, which is each with index, but this one also includes the color, which is whatever element you are referencing this to. And this could be whatever. It doesn't have to be color. It just needs to be a specific case of what you're calling each of the element. You can call it X if you wanted to, but it's good to be specific than generic. And then you also have a place for you to have the index. And sometimes they might be flipped. So this is always the index, and that one is what you reference each of the color. And this one would be the reference of each of the elements. So with either one of these, you always have a case of an index as well as what you reference each one of those elements. So next, let's go into filter. And filter works a little bit differently than all of the other loops and iterators just because of how it works. And essentially, you're just filtering out depending on a condition. So for this particular example, we have colors here, and we're doing a dot filter on these colors. And for each of the colors, we're referencing each one of these elements as color, and we're checking to see if the length of the word is greater than 3. So if it is, then it will return an array with blue and green, or whatever it is you're trying to filter out. So that's how filter works. It actually filters out depending on a condition. And these are really good for deleting. So if you have an array of objects, but you're deleting one of those, you might filter out all the ones except for the one that you're deleting, for example. So that's how filter works. So then let's go into the keyword break as well as continue. And they work very similar of how it would work inside of your conditionals too. So here we actually have a conditional inside of a map. So when we are using it like this way, if the color is blue, if the condition of the color is blue, then we will break out of the loop. If it's not blue, then it will continue on to the next iteration. So that's how break works, is that it will break out of a loop. And then with the continue, what it will do is that it will actually skip or it will continue to the next looping item. So with the continue, what it will do is it will go through red, and then blue, the condition is met continue, then it will go to green. So when we actually run this code, it will print out just red and green because we're just continuing on from blue. But with the break in the previous pass, we will just print out red and blue and just break out of it because it reaches the condition here. So that's essentially how breaks as well as continue works. So let's just wrap everything up. And when we are building out our loops, we need to build them out in a certain way so we don't have our infinite loops. So with infinite loops, it is something that is able to run an infinite amount of times, and there's no way to get out of it until it runs out of memory or processing power, etc. So to avoid and combat that, you need a base case of what you start off with and an induction step. So with the induction step is a way to eventually get out of your loop. So that's why these two things are very important for when you're building out loops, because it prevents infinite loops. And when you're building out your loops, there's multiple ways you can do that. You can use iterators, or you can use the loops that we went over before. But you would just use whatever is most comfortable with what you are using currently. They all are doing some sort of logic until a condition is met. And you can actually be a little bit more crazy with this. You can put a loop inside of another loop or a conditional inside of a loop, but just be careful because it will add on top of the complexity of each of the iterations. So if you're putting a loop inside of another loop, it will do the first loop and then the inner loop. Until that inner loop is done, it will do the next loop iteration and then the inner loop again. And it will add up if you put too much looping power in them. So I would keep it as simple as possible. If you do need multiple embedded loops, I would try to be careful and not to accidentally create an infinite loop or to have it be so much processing power that the computer can't handle. So be careful with loops. It's a very useful tool for a lot of things, and you can actually use them in a lot of applications such as counting, iteration, or if you're trying to do things multiple times. And that's pretty much it for loops. If you have any questions, post a comment below and I will get back to you as soon as I can, and I will see you in the next video. See ya.